All right, now for the exciting conclusion of objects pushed at an angle without friction, practice A. So we're going to be working problems 5 and 6 on this happy thing. This time, instead of pushing or pulling upwards, we're now pushing downwards on things, okay? So like the first problem is a shopping cart. The other time you're pushing a block with a stick, okay? So regardless, here we go. All right, so problem number 5. Let's see, you're at the grocery store picking up all the Red Bull and Pop-Tarts you need for exams. Your cart has a mass of 88 kilograms. It's a lot of Pop-Tarts. You're pushing it with a force of 20 newtons at an angle of 25 degrees below the horizon across a frictionless surface. Draw force diagram, find force applied X, force applied Y, force of gravity, force normal, net force X, and acceleration. Okie dokie. So, that's my shopping cart. I'm pushing like that. FA. All right, now that force applied is going to be broken into its components. We have an FAX, because our angle is right there, and we have an FAY. FAY. Now, other forces acting, as usual, we have a force of gravity pulling downwards, and I got a normal force pushing upwards here. Okay. So, let's go ahead and begin. We are first asked for our FAX, obviously. So, that's the adjacent leg, so that's going to be cosine function. FAX is going to be equal to FA times the cosine of theta. So that's just going to be FA, which was 20, times the cosine of 25. Times cosine 25 gives me 18.12 newtons. Groovy. Next up, we were asked to find FAY. FAY is going to be FA. Now it's the opposite leg, so sine of theta. So 20 times sine of 25 times sine 25 equals 8.45 newtons. All right, groovy. Now, common sense theorem stop. FAX is pushing to the right. We can call that positive. Life is good. FAY is pushing downwards because we are pushing below the horizon. That needs to be reflected in that number. Okay, so we got negative 8.45 newtons here. And we have 8.12 newtons here. All right. Our force of gravity. We're going to assume that this shopping mart is on Earth. Okay, so that's just going to be mass times gravity, which 88 times 9.8, negative 9.8, because it's accelerating downwards, times, I'm getting 862.4 newtons of Pop-Tarts and Red Bull, and I guess shopping cart. So, force of gravity is negative 862.4 newtons. All right, now, solving for our force normal. Keep in mind, we're pushing the shopping cart down the aisle. It is not falling through the floor. It is not being launched off of the floor. So therefore, when we're finding our normal force, we have to take into account that the mass times the acceleration, which is the net force, has to equal 0. Net force in the y direction. So, what are all the forces acting? We've got force applied in the y direction, plus our force of gravity, plus our force normal. Those are the only 3 forces acting in the y direction. So, let's see if I can focus a little bit better. All right, cool. Our normal force in this case is going to be equal to the negative of the force applied in the y direction plus the force of gravity. Fortunately for us, we have already solved for those two pieces. We've got negative 862.4 plus a negative 8.45 in no particular order. All right, so our normal force here, let's see here, negative, open parentheses, negative 862.4 plus a negative 8.45. Don't lose your negatives here. I'm getting a normal force equal to 870.85 newtons. Okay, good. That means we know that. And it's acting upwards. So it's more than the gravitational pull because it's the sum of those two. It has to balance those. So 870.85 newtons. Yay. Now, we are asked to solve for the net force in the x direction. That's just going to be our force applied in the x direction here because that's the only force that's acting on it here. We're just pushing that way. No friction. So that means that that is going to be a whopping 8.12 newtons. Now our acceleration is equal to the net force in the x direction divided by our mass. 8.12 divided by a mass of 88. I'm getting 0.09 meters per second squared. And 8.12 newtons. Ta-ta! All right, cool. Good. Last but not least, number 6. All right, so now we got our 15 kilogram ice block again. M equals 15 kg. It's being pushed with a force of 20 newtons at 55 degrees below the horizontal, and it's frictionless. Draw a force diagram. FAX equals FAY equals FG equals Fn equals, and net force X equals, and our acceleration equals. All right, force diagram, got it, okay. There's my ice block. I'm pushing on it with a stick. That's my FA. I have an FAX. I have an FAY. I have gravity pulling it down. I have a normal force pushing it up. Cool. So now, let's just go ahead and start solving it. I ask you for FAX and FAY first. You should always do that. So, TOA. All right. So, FAX, X is going to be the adjacent leg. So that's going to be FA times the cosine of theta. So 20 times the cosine of 55. Yeah, 11.47 newtons. Groovy. Next up, we have FAY, which is going to be the opposite leg from the angle. So FA times the sine of theta equals 20 times the sine of 55 16.38 newtons. All right, now thinking about this FAX is acting to the right. That can be a positive number. This FAY is acting downwards. That should be a negative number. Okay, so FAY is negative 16.38 newtons. And our FAX is going to be 11.47 newtons. Okay, now I asked you for force of gravity. Force of gravity is just going to be mass times gravity again, right? Our mass is 15, our gravity is 9.8, a negative 9.8. So 15 times negative 9.8 gives us negative 147 newtons. All right, cool. Negative 147 newtons. All right, now our normal force again. Keep in mind, our normal force is going to be figured out by looking at the net forces in the y direction. They have to equal 0. And so, because the mass times the acceleration has to equal 0. And so that is going to be your force applied in the y direction plus your force of gravity plus your force normal. And we were asked to find force normal. There. It's right there. We know our force applied in the y direction, and we know our force of gravity. So, as we have before, our normal force is just going to be equal to the negative of the sum of your force applied y plus your force of gravity. So, our force applied in the y direction was 16.38. Our force of gravity was negative 147. Geez. And we're going to take the negative of that. So, let's see here. Negative, open parentheses, negative 16.38 plus a negative 147 equals 163. Our normal force, Fn, equals 163.38 newtons. Positive, because it has to act opposite of that to support it. So, 163.38 newtons. There is a reason I have worked normal force on all of these problems, okay? It is the key to the next step. Not the whole net force in the x, but the whole where we're going from here, okay? Net force in the x, that's what we're asked for next. That is just the sum of all of the forces in the x direction, which you should be able to tell from our happy little diagram that force is just the force applied in the x. So that's just going to be 11.47 newtons. That's it. All right. Next, it's asking us for the acceleration. Well, is acceleration going to occur? Well, it occurs in the direction of the net force, right? Y direction, net force is 0. X direction is 11.47. So that means our acceleration is going to go in the x direction. So we need to say net force in the x divided by our mass. 11.47 divided by a mass of 15 gives us our lovely acceleration. 11.47 divided by 15, 0.76 meters per second squared. All done. So hopefully this helped you out. Hopefully you're getting into the groove of doing these problems, and the next step is not that big of a leap for you. Okay, so like I said before, if you have any questions, email me. Other than that, I'll see you shortly.